My name is Chris Hinkst, Operations Director at M4 Engineering. Just want to officially welcome you to today's M4 and Oasis joint presentation focusing in on electrical simulation, electromechanical simulation for wire harness design. So let's go ahead and get started. Nabir will now talk to you briefly about M4 and we'll then get into today's presentation. Dan, good morning.
I wanted to introduce M4 and Oasis before we jump into this, and also tell you a bit about Siemens, which is some of the tools that we'll be using. M4 was founded in 2001, and we're really experts in aerospace, renewable energy, and transportation, and pretty much anywhere there is a complex system. When I joined M4 about 5 years ago, we tried to come up with how do we explain that in a very short and concise way, and we came up with the phrase agile intelligence, which we describe as our ability to understand and provide insightful solutions to complex problems. Currently, we're about 50 people, a mix of engineers, technicians, and other type of staff, and we can help companies anywhere from conceptual design through certification support, including detailed design, analysis of different types, optimization, prototyping, and testing. And as you can see here, there's a short list of types of analysis that we perform: trade studies and optimization, multidisciplinary optimization, systems performance simulation, and we're also very competent in the area of composite design, manufacturing, and test. I'd like to tell you a bit about Oasis now. So one of the reasons that we, next slide please, one of the reasons that we chose to work with Oasis is because of their broad expertise in the area of wire harness design. They're really the foremost wire harness expert that we know from a design perspective, and they bring so much experience and knowledge to the table that they are the premier Siemens partner in this area. So really the go-to team that we would look to partner with when it comes to wire harness design. Our expertise, as you can see, is heavily in the area of mechanical design and simulation, and this is where we think this type of webinar would add value. The team at Oasis Sales is represented and worked hands-on with capital electrical systems and wire harness design tools since their introduction into the marketplace. For those of you who don't know what capital is, that's part of the Siemens accelerator portfolio, which I'll talk a bit more in a few slides. No other distributor or Siemens reseller can make this claim. Oasis brings comprehensive application and specific system level expertise, in-depth product knowledge, and proven project experience to support you over the entire life cycle of your project. So we're really, really happy to work together with them, and depending on where your interest may lie, we may end up working together with them, with you, or independently. Next, please. I mentioned the accelerator portfolio briefly, so I wanted to tell you a bit more about what Siemens refers to as accelerator. It's a portfolio of tools to help you develop a digital enterprise, some of which we'll touch upon today, like Capital and SimCenter, a few of the tools that might be able to help you, and all of them work together to help you speed up your digital transformation. So you may be wondering, why do you need to work on a digital transformation? Well, part of it has to do with the explosion of complexity, right? Nobody is doing things the way they did before, and if they are doing it, they probably won't be doing it for long because other people are encroaching into their space. Not to mention the fact that the products themselves are becoming more complex and more complicated, integrating electrification into the process, integrating connectivity, Internet of Things and such. So as companies are looking to ways to take advantage or to overcome some of these challenges, they're looking to build something called the digital enterprise, which at its core has something called the digital twin and digital thread, and all of these are terms that you may have heard about. But regardless of whether you heard about them or not, Siemens is able to help you with that, and through its resellers like Oasis and M4, we can work together with you and try and help you down this path. So to bring a comprehensive digital twin to life, Siemens offers the accelerator portfolio, which is basically a mix of software services and development of different types of application that can accelerate your digital transformation. It unlocks a powerful industrial network and allows you to blur the boundaries between traditional standalone engineering domains like electrical, mechanical, and software, and bringing them together into more of a collaborative environment across the product and production lifecycle stages. its solutions get streamlined, customized, and delivered through the Siemens ecosystem, including partners like Oasis and M4. So the vision for tomorrow is an optimized network of digital enterprises working together. So not only would you be working internally, but being able to collaborate with other companies leveraging this type of technology that touches upon design and analysis and manufacturing and IoT analytics and everything else that you might be thinking about. So the webinar itself really is just part of this whole digital transformation, and I hope this helps put some of the the content that we'll present in context. Before we begin, I'd like to introduce you to our presenter, Vitaly Rezakulov. Vitaly is a senior engineer at M4 and manages our technical sales team, which covers application engineering, technical support, training, and mentoring. He also works as an analyst and a program manager and has been at M4 for about 9 years. He's performed various types of design and analysis, but if you ask him what his key areas of expertise are, he might mention structural analysis, statics, dynamics, fatigue, and a broad experience with many of the different commercially available and government industry standard FEA tools. By the way, he is in fact older than he looks in his photo and is aging rapidly due to his 2 young boys, one about 3 and the other at around 4 months old. So without any further introduction, I'd like to turn it over to Vitaly. I hope you enjoy the webinar.
Thank you for that introduction, Dan. And hello, everyone. And I am here to talk to you about a tool that I am very excited about called SimCenter 3D Flexible Pipe. I'm really excited about it because of the complexity that is able to capture while keeping the user interface extremely simple. SimCenter 3D Flexible Pipe is a unique tool. It enables faster and more accurate design of flexible pipes, cables, and harnesses. So let's set the context. Cars, airplanes, and everything in between are becoming more sophisticated, more connected. Electrification is changing how we power things. Smart devices are integrated into everything around us. A side effect of this, of course, is not only increasing numbers of cables in different systems, but the increasing complexity of these systems. So how should the modern engineer approach the design of cable systems? The traditional way was to follow a design, prototype, test, and then redesign process. Because of the limited capabilities of engineering tools, companies have been forced to conduct long, expensive, and iterative cycles to qualify their cable systems. We also know that these tests grow in complexity and size as we enter the system level stage. The effect of this is significant friction that slows the design process dramatically. Finally, the inability to accurately simulate cable systems and specifically the physics in these systems results in product recalls due to broken cables, harnesses, hoses, and pipes. These recalls not only cost a fortune and endanger the customer, but they also damage the reputation of the companies that are involved. Within this context, flexible pipe is a modern solution that reduces time for simulation by implementing a designer-centered interface that is fully integrated with the CAD system. It also reduces prototyping by accurately capturing the complex physics involved in these systems. This, in turn, reduces the number of recalls. The end effect is a shorter design cycle, fewer test campaigns, better products, more successful companies. To drive the point home, let's reflect on the costs associated with some of the following real recalls by some of the industry-leading companies in the last few years. In the automotive industry, Toyota recalled 1 million hybrid vehicles due to engine wire harness issues that can lead to fire risk. The wire harness, which connects the hybrid power control unit, can come into contact with the covering at the connection point. Ford recalled 225,000 vehicles again to fix a wiring issue. They tried to deal with a cruise control problem by installing new wiring harnesses, which turned out to be defective. BMW launches a huge recall of 300,000 vehicles over an issue with a cable that poses fire risk. The issue was thought to be responsible for several fatal crashes in the UK. Finally, in the aerospace industry, the Airbus A380 program was delayed because during installation, the cable systems were found to be, of all things, too short. They had to remove and replace all the cable systems on the airplane. Moment of silence for not only the financial cost of these recalls, but the schedule delays, reputation costs, and most tragically of all, the fatal crashes that were a direct result of design tools that were not up to par. So how do we get out of this predicament? A quick survey will show you that CAD-only or simulation-only tools will not be able to deliver the needed solution. CAD is not able to capture the needed physics, vibration, stress, collisions, friction. On the other hand, while FEA can capture the needed physics, its difficult data input and the analysis-centered environment will fall short of the requirements of the design lifecycle. The solution is to integrate the needed physics into a designer-centered environment. The environment has to take into account the complexity of contact, static and dynamic analyses, vibration, and simplify it into an efficient and easy to use tool that will drive the cable system design process forward. The end result of this process is drastic cost and schedule savings and reduced recalls by preventing bending, torsion, fatigue, and dysfunction of the cable systems. The required solution needs to have three key attributes. First, an easy-to-use interface that enables the user to input the required material data using a simplified format that maximizes the available data. Second, it should incorporate a leading and efficient solver that can accurately and quickly capture the required physics, including curvature and deflection of cables, permanent deformation, contact, static, and dynamic behavior. Finally, it should leverage a post-processing interface that allows the user to visualize the mechanical behavior of the system and extract any relevant results. This is the approach taken by Flexible Pipe. To start, let's focus on characterizing the material inputs. It's harder than it sounds. Flexible Pipe is actually able to maximize a limited scope of testing to build material models that accurately capture the behavior of the actual cable systems. The system uses inputs from simple physical testing, things like 3-point bend tests, torsion, simple tension tests, as well as any available virtual simulations and tests. These data are fed into Flexible Pipe. Flexible Pipe is then able to optimize a material model to the input data to minimize differences between the model output and the test data. Flexible Pipe does all the hard work so that you don't have to. The result of this kind of material characterization is the development of what is called a digital twin of the cable. A digital twin is exactly what it sounds like. It's a digital version of a physical object that captures the physics of the object and behaves as the actual object would. This process of using physical tests to come up with a digital twin of the cable system forms step 1 in the material characterization process. In step 2, we define the properties of bundles of cables, and Flexible Pipe will use the material database formed in step 1 and the digital twin of each cable to come up with an equivalent, simplified model for any combination of cables. This includes joining techniques, used various taping methods and spacers and things like that. All of this is done virtually and doesn't require any additional physical testing. One thing to note is that you don't have to have a deep knowledge of nonlinear material models to go through this process. The third step is to use the database generated from step 1 and step 2 to map onto cable systems from the NX routing module. Flexible pipe can automatically assign material properties to NX routing elements with the corrected identified materials. If the cables are the same as the cable modeled in the first two steps, they will be assigned the same material properties. Flexible pipe will then perform several analyses to determine a mean spline for the cable bundle, and this information will be fed back to NX routing. The two are interconnected and integrated. Now we'll talk about the other two components of the solution, the solver and the capture of mechanical behavior. Here we will highlight just some of the key features offered by flexible pipe that enable us to efficiently capture the cable system physics and to visualize the important system behavior. First, instantaneous update. As you can see in the first video, flexible pipe integrates a fast previewing solver enabling quick checks on pre-design. Second, a link with NX routing. Flexible pipe has a bidirectional link with NX routing, allowing an existing user to avoid recreating his full harness. All of this is done with a single click. The third, permanent deformation. Flexible pipe is able to accurately capture the nonlinear permanent deformation of cable systems. As we know, this physical behavior will influence the cable deformation and in turn may lead to collisions with other systems. Fourth, dynamics of a complex harness. Stretch limits, reaction and extraction forces, bending, twisting, and stresses may be checked against applied movements. Then the design may be optimized to respect given constraints and limits. We can look at very complex and dynamic systems. Fifth, flat electric cables. Flexible pipe has a shell representation of cables that it's able to use. This enables us to model flat cables as, for example, a camera light opening and closing. Contact with close surrounding surfaces is taken into account. Sixth, plastification. When cyclic and repeated movements are applied, as for example, in door sliding and opening, roofs, harnesses connected to steering systems, deformed shape evolves, leading to potential collision problems. Additionally, the plastic stresses that are developed are accumulated, reducing the lifetime of the cable systems. In summary, flexible pipe incorporates a solver that is able to capture the key physics of cable systems. It is also able to visualize the most important behaviors of these systems, enabling us to create better wire harness systems faster. Another thing to note about flexible pipe is that it integrates into the Siemens product design ecosystem. As an example of what this could look like, we have first 2D logical diagrams that can be created with ECAD tools like Capital. We then transition into MCAD design that can be performed using the NX routing module. This results in 3D wire layouts and bills of materials. We then proceed to SimCenter 3D flexible pipe, which performs the validation and optimization of the cable systems. Are the stresses and strains acceptable? Are there collision problems? Are the cables too short or too long? Are there strains induced from prepackaging? Flexible pipe can work with the NX routing module to create a new design from an existing design based on defined constraints. Finally, the whole process can be managed within the Teamcenter product lifecycle management system. Think of all these integrations as ways to magnify the impact of SimCenter 3D flexible pipe. I could spend a lot longer talking about flexible pipe and all the different features. A lot of them are really interesting and really cool. And if you are interested, please ask for more information from our sales team. But to be respectful of everyone's time, I wanted to highlight 4 key takeaways. First, flexible pipe enables virtual redesign, saving expensive and time-consuming design prototype iterations. Second, flexible pipe enables you to capture real-world physics, which can enable you to avoid costly recalls. Third, flexible pipe integrates into the full Siemens suite of tools that include ECAD, MCAD, Teamcenter, and many other solutions that are growing day by day. Finally, flexible pipe is a industry-leading and validated solution that has already been implemented by companies such as Daimler to enhance their electrical routing process. Some of the challenges that Daimler faced in the design of brake pipes was a need to reduce the iterations between product designer and manufacturing process designer, as well as the need to design safer, faster, and right the first time. By incorporating flexible pipe into their development process, they were able to capture the motion of the brake cable moving with the suspension kinematics, which enabled correct simulation of the mounting scenarios. The ability to use static and dynamic simulation enabled them to prevent collisions with other components, hot components, and excessive bending, torsion, and other parameters in the cable system. All of this reduced the risk of fatigue and dysfunction for the cables. In summary, the current approach to design of cable systems is inadequate. A designer-centered solution that captures the complex physics of cable systems is needed. Flexible pipe enables next-level cable system design that reduces recalls, improves product quality, and leads to better designs faster.
Thank you, Vitaly. I hope everyone enjoyed the presentation. I know that even though I've heard and seen it before, I always find additional insights when I see it again. In the interim, if you could please submit any questions via the questions tab, and while we sort through some of your questions, you might be interested in what else you can do to help you move from here towards exploring anything you might have learned today, or might help your organization, or maybe there's something else that we can do to help you down the path of the digital enterprise. So here are some of our thoughts or ideas of how we might be able to start exploring what's next. We can schedule a short call to discuss your current situation, challenges, and their impact on your business. And depending on the area of interest, it could be either M4, Oasis, or both of our companies at Siemens, that can help. We can also schedule a short process audit to better understand how leveraging simulation into your wire harness design and manufacturing process can potentially reduce costs and improve your efficiency and product performance. And of course, you're welcome to send us an email with any information or any stuff you'd like to share or receive from us. You have my contact information here. Use me as a primary contact, and once again, depending on the area of the inquiry, I will forward it to our partners at Siemens and Oasis, or whatever is needed to help you get an answer. Also, before we go to the answers on the Q&A section, I wanted to remind you that there are 2 handouts that are available for download on the link here on the webinar. One of them is a Siemens software flexible pipe add-on fact sheet for an X, so if you want to learn more about that. And then the other one is 12 ways that Oasis makes wiring and harness design faster and better. Oasis is one of the Siemens tools as part of the Accelerator portfolio.
So the first question we have, Vitaly, is flexible pipe a tool for analysts? That's part 1. And then part 2, will it be hard to use for a designer?
Yeah, good question, Chris. So I would say that flexible pipe was designed from the ground up to be specifically for designers. This shows up in many of the aspects. First of all, it's a CAD integrated tool. Second, you have the simplicity of entering material data and how that data is used and maximized by the software. And in general, you don't need to be an analyst to use this tool.
How hard is it to create material models?
Yeah, great question. Yeah, as I pointed out, flexible pipe makes this really easy, and it basically boils down to you use whatever testing data that you have available. So for example, tensile testing, 3-point bend data, torsion testing. If your company doesn't do its own testing, M4 does do testing as well, so we're glad to help with material characterization. But you take what you have, you feed it into flexible pipe, which is then able to create or select a material model and tune the material model in order to minimize the differences between the material model outputs and the testing that you provided. If some of you may know, this is actually a pretty difficult task, so that the fact that the software optimizes this and does this for you is pretty incredible.
All right, Vitaly, another question from the audience is, can I use flexible pipe without using the Siemens PLM and ECAD?
Yes, you are able to use the flexible pipe tool without using some of the other Siemens tools like ECAD and the Teamcenter PLM system. The only note is that these tools are just magnify the power of flexible pipe, and the like Dan mentioned, the full ecosystem really enables the full digital transformation, but there is nothing to prevent you from using flexible pipe as a standalone tool and reap the benefits I described.
Awesome, excellent. Really do appreciate your insight on that. Okay, another question that just came in is, can the cable properties be saved in a database or something similar?
Yeah, so that's a really good question. Yeah, and working with various customers, I find that this is a common theme of like 30 different people have 30 different material databases. Flexible pipe enables you to create like a company database or a user database, if you want to save one for yourself. But yeah, there's really cool things you could do, like have a controlled material database for your whole company that everyone pulls from. The nice thing is that it really enables and facilitates reuse, so you don't have to go redo testing all the time because you lost, the test data somewhere. It's all saved within the system.
Excellent. All right, moving right along here. Another question that just came in. I'm going as fast as I can. Which solver does flexible pipe use?
So flexible pipe uses the LMS Samtec solver, and the solver is able to do both static and dynamic analyses, can handle vibration, dynamics, linear and nonlinear. It can do some really, really neat and cool stuff. Some of what I've touched on, like contact and plasticity, all of these things are important, and it's pretty amazing that it's able to look into all of that.
Just a couple quick items is our next webinar is on July the 22nd with our friends at Oasis, and we're going to be focusing in on electrical system complexity at a tipping point. So look for more information on LinkedIn and emails as we share that information to you and hosting that next webinar on July the 22nd. And also on Oasis's YouTube channel, we'll make sure to have the recording stored there as well. We appreciate the opportunity to serve you and providing you with meaningful content. Vitaly, thank you very much for your insightful information around wire harnessing, and we look forward to talking with each and every one of you in the very near future.